Assalamualaikum warahmatullahi wabarakatuh. Today we are going to talk about application of geometry in real life. So, what is geometry? Geometry is a branch of mathematics that deals with the study of shapes, sizes, positions, and property of objects in space. The word geometry comes from the Greek word geo, meaning earth, and metron, meaning measurement, showing that geometry was first used to measure lengths. Geometry helps us to understand the world around us by studying points, lines, angle, surfaces, and solid objects. It is used to calculate length, area, volume, and angles, and to analyze how shapes are really related to one another. So, does geometry really matters? It does. For real-life application, as geometry is used in building houses, designing roads, creating maps, and making artworks. Architects, engineers, and designers rely on geometry to plan and construct safely and accurately. Second, for everyday uses, we use geometry when measuring rooms, packing objects, cutting materials, or even playing sports. And lastly, for problem-solving skill. Studying geometry improves logical thinking and helps us solve problems step by step. So today we are going to present two cases of application of geometry in real life. And we are going to present ice cream and tumbler. Let's go on to the first case, which is ice cream. The evolution of ice cream started from the ancient times from all around the world. Ancient China, around 200 BCE, people mixed snow or ice with milk, rice, and fruit juices. This is one of the earliest forms of ice cream. And from ancient Persia, they made a frozen dessert called fajule using iced rose water and tin noodles. And from the Middle Ages, Arab world introduced milk-based frozen dessert flavored with sugar, which has a very major improvement. Marco Polo from the 13th century, it is believed that he brought frozen dessert recipe from China to Europe, helping to spread the ideas. Nowadays, the invention of refrigeration allowed mass production for ice cream. Many new flavors, cones, and styles were developed. Today, ice cream is enjoyed worldwide in countries in different flavors and forms. General information about ice cream. So first, vanilla is the most popular flavor worldwide. Second, ice cream melts faster during the hot day because of heat transfer. Third, July is known as the National Ice Cream Month. Fourth, ice cream is very refreshing during the hot weather. Fifth, ice cream comes in different flavors and textures. And lastly, ice cream is often linked for celebration and happiness.
A factory produces ice cream consisting of a cone with a spherical scoop on top. The radius of the cone and the radius of the sphere are each 3 cm. The height of the cone is 12 cm. The melt ice cream is stored in a cylindrical container with a radius of 15 cm and a height of 40 cm. In this question, we are going to use pi equal 22/7. First question is calculate surface area of the ice cream cone. We're going to use formula S pi r. S is length height. To find S, we need to use Pythagoras theorem, which is square root of 12 square plus 3 square. We are going to get S equal to 12.3693 cm. The surface area of the ice cream cone is 12.3693 multiplied 22/7 multiplied 3 equal 116 centimeter square. In question B, calculate the volume of the ice cream cone. Formula for the volume of ice cream cone is 1/3 pi r square hash equal to 1/3 multiply 22/7 multiply 3 square multiply 12. We will get the answer equal to 792/7 centimeters cube, which equal to 130.14 centimeter cube. In question C, we are going to calculate the volume of the spherical scoop. The formula is 4/3 pi r cube. After we insert the radius into the formula, we will get 4/3 multiply 22/7 multiply 3 cube equal to 130.14 centimeter cube. For question D, calculate the total volume of one ice cream, where we need to sum up the volume of ice cream cone and the volume of the spherical scoop, which is 130.14 centimeter cube plus 130.14 centimeter cube equal to 226.28 centimeter cube. For question E, calculate the volume of the cylindrical container used to store the milk ice cream. Formula for this question is pi r square hash used to be 22/7 multiply 15 square multiply 14. So that 198,000/7 equal to 28,285.71 centimeter cube. For the question F, determine the maximum number of ice creams that can be produced from the container to sum up volume of container over volume of one ice cream, where is going to 28,285.71 over 226.28 equal to 125. For the last question is if 10% of the milk ice cream is washed during the production process, calculate the actual number of ice creams that can be produced, where is 100% minus 10% equal to 19%. 19/100 multiply 125 equal to 112.5.
The history of the tumbler began in the 19th century with the invention of the vacuum flask by Sir James Dewar, which became the foundation of insulated bottle. However, the term tumbler itself originally referred to an ancient drinking glass without a flat base, making it easy to tip over. During technological development 19th to 20th century, invention of the thermos in 1892, Sir James Dewar invented the vacuum flask using a vacuum chamber, which became the precursor to insulation technology for maintaining beverage temperature. Practical innovation in 1946, Frank Cotter and G. Hewlett Davis created a smaller portable double-wall insulated tumbler, and innovation derived from large thermos bottle. Plastic era in 50s to 60s, where the use of plastic made tumblers more popular, lightweight, and better at maintaining temperature. On 21st century, modern tumblers are more than just containers. They emphasize aesthetic, personalization, and have become part of sustainable lifestyle trends. The materials are made from various materials such as stainless steel and plastic. They feature advanced insulation and a wide range of designs. A fun fact about tumbler. A tumbler helps keep drinks hot or cold for hours, support an eco-friendly lifestyle, and makes staying hydrated easier.
Aaron wants to stay hydrated since the temperature outside increases over time. Therefore, he is planning to drink 8 glasses of water daily. Each glass has the same height and radius, which is 10 cm and 3.9891 cm. Aaron has a water bottle with 20.6 cm height and 7 cm diameter. We're going to use pi equal to 3.142 in this question. In question A, we're going to calculate the volume of a glass of water. We're going to use the formula pi r square h equal to 3.142 multiplied 3.9891 square multiplied 10. And the answer is equal to 499.9839 centimeter cube. Question B. Calculate the volume of water Aaron has to drink in a day. For this question, we need to take the volume of the glass of water multiplied by 8. The answer is equal to 3,999.8712 centimeter cube. For question C, we need to calculate the volume of Aaron's water bottle by using the formula pi r square h. First, we need to find the radius by dividing the diameter of the water bottle by 2. And we will get the radius equal to 3.5 cm using the formula pi r square h equal to 3.142 multiplied 3.5 squared multiplied 20.6. And we will get the answer equal to 792.8837 cm cube. Question D. How many times does Aaron need to refill his water bottle to achieve his goal? In this question, to get how many times does Aaron need to refill his water bottle is by divide the volume of water he needs to drink for one day with the volume of his water bottle, which is 3,999.8712 divided by 792.8837, and we will get the answer is equal to 5.0447. So Aaron needs to refill his water bottle at least 6 times to achieve his goal. In conclusion, this case has provided a comprehensive understanding of fundamental geometric principles, including the properties of shapes, angles, and measurements. By applying relevant theorems and formulas, the assignment has reinforced analytical and problem-solving skills while emphasizing the importance of precision and logical reasoning. Furthermore, it highlights the practical applications of geometry in various fields such as engineering, architecture, and science. Overall, this assignment has contributed to a deeper appreciation of geometry as a vital branch of mathematics and has strengthened the ability to apply theoretical knowledge to structure problems.
Selamat